Hello friend, today we will work on random forest classifier, which is used in house price prediction, loan risk analysis. First of all, import library, which is import numpy as np, import matplotlib.pyplot as plt, import pandas as pd. Then after we will import dataset, which is dataset equal to pd.read_csv bracket open r single inverted comma e slash, then we will give location. Copy your dataset location and paste in your program. Now we can see the detail of dataset. Now we will extract data into dependent and independent variable. For this we will write x equal to dataset.ilog square bracket open colon comma square bracket open 2 comma 3 square bracket close dot values. Here we use ilog to assess element by their position rather than their name or their label, and colon is used for select all the rows in the dataset. As we know that Python indexing start from 0, so that we use 2 comma 3 to select third and fourth column. Dot values we use to convert the selected column to the numpy array. Now we will split the dataset into training set and testing set. Here x represent two independent variable. It could be income, purchase, age, other measurable input, and y is represent to dependent variable. It could represent the outcome we are trying to predict, such as house price prediction. Train_test_split is used to split data into training and testing. Test_size equal to 0.20. It means 20% of the data will be used for testing and 80% will be used for training. Random_state equal to 0. We use this to control the random shuffling of data before splitting it. Now we will do feature scaling process. For feature scaling we will type from sklearn.preprocessing import standard scaler sc equal to standard scaler bracket open close and x underscore train equal to sc.fit underscore transform bracket open x underscore train bracket close. We use standard scaler to scale the features. Fit underscore transform, fit to compute the mean and standard deviation for each features in the training set, and transform will apply the scaling using the computed mean and standard deviation. X underscore test equal to sc.transform bracket open x underscore test bracket close. This will apply the same transformation to the test data. After completion of feature scaling, we will import random forest algorithm from machine learning. For this we will type from sklearn.ensemble import random forest classifier. This is a class from the sklearn.ensemble module that implement a random forest algorithm for classification. As we know that random forest is an ensemble of decision trees, it works by creating multiple decision trees during training and then making prediction of individual trees. Classifier equal to random forest classifier bracket open n underscore estimators equal to 125 comma criterion equal to entropy comma random underscore state equal to 0 bracket close. Here n underscore estimators equal to 125. These parameters specify the number of trees in the forest. In this case, 125 decision trees will be created in the forest. And criterion equal to entropy. This defines the function used to measure the quality of split in the decision trees. Random underscore state equal to 0. We use this to ensure that the results are reproducible. Classifier dot fit bracket open x underscore train comma y underscore train bracket close. This line trains the random forest classifier model using the training data. X underscore train is an input variable, y underscore train is an output variables. The next step is we will predict x text. So now type y underscore pred equal to classifier dot predict bracket open x underscore test bracket close. Now we will do confusion matrix process. Now we will type from sklearn dot matrix import confusion underscore matrix. For this we will type cm equal to confusion underscore matrix bracket open y underscore test comma y underscore pred bracket close print bracket open cm bracket close. A confusion matrix helps in understanding the performance of a classification model by showing the actual versus predicted class level for the test set. Now we will check the accuracy of data. For this we will type from sklearn dot matrix import accuracy underscore score. We check accuracy because accuracy is a basic matrix for evaluating a classifier by measuring the proportion of correct prediction out of the total predictions. In this accuracy underscore score, this function compares the true labels with the predicted label from the model. Now we see the output, the accuracy which is 0.93. Let's check bias. Bias equal to classifier dot score bracket open x underscore train comma y underscore train bracket close. We use bias because the accuracy score on the training data is assigned to the variable bias. Bias is more commonly referred to the training accuracy. Here the output of bias is 0.99. To check variance, we will type variance equal to classifier dot score bracket open x underscore test comma y underscore test bracket close. Variance referred to as test accuracy. The output of variance is 0.93. The notable point is when training and test accuracy will similar, model is generalizing well. Now we will write the coding to visualize the training dataset. For this we will type from matplotlib.colors import listed color map. Listed color map will allow us to create a color map using a list of colors. X underscore set comma y underscore set equal to x underscore train comma y underscore train. This assign the training features and labels to x underscore set and y underscore set. Here we are using the training data to plot the decision boundary and visualize how the classifier performed on the set. Now we will create mesh grid. For this we will type x1 comma x2 equal to np dot mesh grid. Mesh grid is used to create 2D dimension array that represent the grid of points in the feature space. This grid is used to visualize how the classifier predicts the class for every point in the 2D plane. np.arrange. This will generate the range of values for both features x1 and x2. Step equal to 0.01 ensures that the grid is fine enough for smooth plotting of the decision boundary. plt.contourf function plots the decision region. The region based on the predicted class, that is red for class 0, green for class 1. Classifier.predict method predicts the class level for each point in the grid. It returned an array of prediction. .travel function flattened the arrays x1 and x2 into 1D arrays so that they can be passed into the classifier. .reshape bracket open x1 dot shape bracket close. After predicting the class for each point in the grid, the predictions are reshaped back into the original grid shape so that it can be plotted as a contour. Alpha equal to 0.75. This will set the transparency of the color, allowing you to see both the decision boundary and the data point more clearly. plt.xlim bracket open x1 dot min function comma x1 dot max function bracket close. This line will set the limits of the x-axis and y-axis to the minimum and maximum value of the grid. This will ensure that the entire decision boundary and data point are displayed within the plot. Colors equal to np.array bracket open square bracket open red comma single inverted comma blue single inverted comma close square bracket close large bracket close. This will create an array colors that holds two colors value, red and blue. The idea is to map class 0 to the colors red and class 1 to the color blue. For j in np.unique bracket open y underscore set bracket close, the loop iterates over each unique class label in the target value, which is y underscore set. If there are two classes, that is 0 and 1, the loop will run twice, once for each class. Here np.unique bracket open y underscore set bracket close. This will use to return the unique class label, which is 0 and 1 from the training set. plt.scatter function, we use this to plot each data point as a scatter plot on the graph. X underscore set square bracket open y underscore set equal to j comma 0 square bracket close and x underscore set square bracket open y underscore set equal to j comma 1 square bracket close. This will be used to select all data points belonging to class j. For example, if j equal to 0, it select all the rows where the label is 0. To add title, we will use plt.title function. To label the axis, we will use plt.xlabel and plt.ylabel. plt.legend function, the legend will show the color associated with each class based on the label specified in the plt.scatter function. plt.show function, this will use to display the plot on the screen. By using this coding, we can visualize the data into testing set and training set. Now we are doing coding to visualize the testing dataset. To see output, you can check the difference between training and testing dataset. Thanks for watching this video.